Okay, so the discriminant used by that little delta symbol is that section of the quadratic formula that's under the square root sign. So b squared minus 4ac. Let's think about that. If that expression there is greater than 0, so if b squared minus 4ac is greater than 0, that means we get plus or minus the square root of a positive number. Therefore, we get two solutions to that, so no problems. If the discriminant is less equal to 0, I get minus b plus or minus the square root of 0, which means all I get is one solution. Okay, so if the discriminant is equal to 0, I get one solution. If the discriminant is less than 0, I get minus b plus or minus the square root of a negative number, which has no solutions. Therefore, we get no real solutions or no x-intercepts. So really, just by looking at the b squared minus 4ac, we can tell how many solutions we're expecting to get. So if we consider each of these discriminants, so if a is equal to 1, b is equal to negative 6, and c is equal to 2, the discriminant, which is equal to b squared minus 4ac, is equal to negative 6 squared minus 4 times 1 times 2, which is equal to 36 minus 8, which is equal to 28. Therefore, I get two solutions. Okay. If I look at the next example, I get a equals 1, b equals 2, and c equals 1. So the discriminant, which is b squared minus 4ac, is equal to 2 squared minus 4 times 1 times 1, which is equal to 4 minus 4, which is equal to 0. Therefore, I get one solution. So if we consider x squared plus 2x plus 1, if we factorise that, I get x plus 1 all squared. And the graph of that is that, isn't it? One intercept, one solution. That's what that discriminant tells me. If I go to the final example now, and let's have a look at a equal to 1, b equal to negative 2, c equal to 4. Therefore, my discriminant is equal to negative 2 squared minus 4 times a times c, which is equal to 4 minus 16, which is negative 12. Therefore, I get no solutions. So again, if I was to complete the square on that particular one, I get y equals x, halve it and square it, plus 1 minus 1 plus 3. So the turning point would be at 1, 3. So if we graph that, my parabola's got no x-intercepts, therefore no solutions. Okay, state the nature and the number of roots for each of these equations. So again, the number of roots is the number of solutions. So a equals 1, b equals 8, c equals 7. Discriminant is equal to b squared minus 4 times a times c, which is 64 minus 28, which is equal to 36. So note, 36 is a perfect square. So not only do we have two solutions, but I get two rational solutions. And what that means, if we consider our quadratic formula here, I'll get minus b minus 8, x will equal minus 8 plus or minus the square root. Well, b squared minus 4ac is 36. We've just worked that out over 2a. So x will equal minus 8 plus or minus 6 over 2, which is negative 8 plus 6 over 2, which is negative 1, negative 8 minus 6, negative 14, negative 7. So my two solutions are rational numbers, and that happens because 36 is a perfect square, and we can square root that. Question 12 is a more typical kind of example. Find the values of m for which our solution has 0, 1, or 2 solutions. So for the number of solutions means we need the discriminant. So the discriminant is equal to b squared minus 4 times a times c, which is equal to 4m squared, 3 3s are 9, minus 36. So that's my discriminant. Now to get one solution, so let's come over here. For a, one solution means the discriminant is equal to 0. So I get 4m squared minus 36 is equal to 0. M squared is equal to 36 on 4, which is equal to 9. So m equals plus or minus 3. So if m is equal to plus or minus 3, we get one solution. Now for greater than 0 and less than 0, let's go back and sketch the graph. So 4m squared minus 36 is the graph of x squared, or m squared, down 36 units, so that's there. And the intercepts are at plus or minus 3. So I get there equal to 0, and let's just continue it on. Greater than 0, and that's negative 3 and positive 3. So don't forget that this is my discriminant, and that's x. So no solutions for part B. No solutions. The discriminant has to be less than 0, which is that blue section, which means the m value, negative 3, is strictly less than m, which is strictly less than 3. Because if it's equal to 3 or negative 3, we get 0, which is one solution. And then obviously for part C, I want the section out here where it's greater than 0, where I would get two solutions. So I need m is greater than 3, and I'll put a union, m less than negative 3. So there's my three sections, okay? Okay, so very similar question. Consider the quadratic equation, find the discriminant. So discriminant is equal to b squared minus 4ac. So the discriminant is equal to b squared 4 times a times c. So that's equal to 36 minus 8, 16p, and that's what the discriminant is equal to. So for part B, find the values of p for which there are two solutions. So two solutions means the discriminant is strictly greater than 0. So therefore, 36 minus 16p has to be greater than 0. So 36 has to be greater than 16p. Therefore, p is going to be less than 36 on 16. 4 goes into that, doesn't it? Which is 9 on 4. So p has to be less than 9 on 4 for two solutions. No solutions. Let's just change our colour. Means the discriminant is going to be less than 0. So simply that means 36 minus 16p is going to be less than 0. You see the math is going to be very similar. Just the sign's going to be the opposite, isn't it? One solution means the discriminant is equal to 0. So I need 36 minus 16p to be equal to 0. And we'll obviously get p equal to 994. So as soon as you see a question that asks about the number of solutions, your data, your thought processes need to take you to the discriminant and working with that.